color quiet.
All right, so I want us to continue with the conversation from where we ended last time. We are still looking at transportation models. And in the previous conversation, we made mention that transportation models has a concept where the goods, right, are being transported from different sources to different destinations. All right. There are different destinations where the goods are being transported. Now, the idea is that when you're transporting those goods, we have to do it in such a way that we minimize the costs of transportation. Cost of transportation is to be minimized. Clear?
Clear, sir.
Yes. And after that, we recorded to us that the key areas of interest that we need to pay attention for the purpose of any examination. Number one is actually to know how to find the basic feasible solution. Yeah, the basic feasible solution. And from there, we should be able to find the optimum solution, optimizing. And of which last time we had time using 3 different methods, to look at the basic feasible solution discovery. We learned how to find the basic feasible solution. And the following are some of the methods that we talked about. Number 1, the northwest corner rule method, yeah? The northwest corner rule. And the second one we had was the least cost sale method, the least cost sale method. And finally, we had the Ogle's approximation method, VAM. So after looking at all these 3, we learned how they are used, to find the basic feasible solution. Now, as of today, we are riding on what we did in the previous class. The question can come, a follow-up question after finding the basic feasible solution. Can you now find the optimum solution using, say, for example, northwest corner rule, or using the least cost sale method, or using the VAM method? So you need to understand that, okay? So in the interest of time, let's assume that we are going to find the initial basic solution, because that's where we start from. We're going to find the initial basic solution using the northwest corner rule, really. We can just use, for example, the northwest corner rule, and we'll still be fine. You can even use the least cost or the VAM, whichever. The question will be very clear. You should be conversant with all of them. Is that clear?
Yes, sir.
Yes. So let's use the northwest, where we are looking at the costs. We are starting with the northwest corner that we have here, and when we get here in this cell, we look at we choose the minimum of either the demand or the supply from this side. Yeah, the minimum of them, which is 250. So we allocate 200, 200 and 250. 250. And again, once we do that, you know that this this column, the first column, yeah, pay attention. The very first column has what? Has finished being allocated. So we'll cancel this and that, because this is 250 versus 250. This side will remain with what? Out of 300, we have already allocated 250. We'll just remain with 50, isn't it? That's what we did, right? Oh, hello?
Hello?
Yeah,
Hello?
yes. Okay, so that's that. And we are done with this column. And then the next northwest obviously is this one on 1, right? this one on one. And we need to put the minimum between this 350, the demand, and 50 there. We know that 50 is the minimum. We shall put 50. And then when you put 50 there, down here will remain with what? With the 250, isn't it? We just
Yes.
remain with the 200, 250. When all that has been done, then what you shall do from there is that
Are we not
you're going,
supposed to remain with huh? Are we not
we are
supposed to
remaining with
remain with
300.
300? Yes.
Yes, we should remain with 300. Thank you for that. We are remaining with 300. Mhm. Remaining with 300. And then this one and this one will cancel because it's done in terms of their location. Then the next west corner rule shall be what?
2.
The next west will be which one?
For the next one, it will be 6.
Yeah, you come
No,
on
not
6.
6. No, yes, 6.
Yeah, 6. 300 versus 400 is 300. 300 is the minimum. All right. So we know that this is 300 and this is the total, which means this one will be cancelled, right? And
Yes.
then this side you just remain with 100,
Mm-hmm.
right? And again, the next west corner is what?
5.
It's 5. 400 versus 100. We just record 100, right? Yes, it's the
Mm-hmm.
smallest. And then we'll have to cancel that so that here we remain with what? 300, isn't it?
Yes.
And the next west corner rule shall be what? Shall be
3.
applied on these 3. So apply 300 here, then and the remainder this side will be what?
It will be
300 will be 200.
200. 200,
Then
yeah.
200 versus 200 shall be allocated here as 200. You have followed, yeah?
Yes.
Now, when you finish getting this, when you reach this stage, right? The follow
Mm-hmm.
nice, once you're done doing this, then you need to find, the basic solution. How is the basic solution found? You check on those that are optimized, just those that are optimized. Even today, you don't have a calculator.
Yeah.
250 times is free plus 50 times 1, right?
Mm-hmm.
Plus 300
300.
times 6 plus 100 times 5 plus what?
Plus
Plus 300
300 by 3.
by 3 plus
200 by 2.
200 by what? By 2.
So,
So when you do your consolidation, this will be 750 plus 50, that will be 800. This will be 1.8. 300 times 6 is 1.8. 1.8 plus 500 will be 23 plus 900. What is 23 plus 900? Also plus 400, that is 13. So 23, we're looking at 23 plus 13 plus 800. So this is
but
going to
800 or
be,
200, sir.
which one?
The last one. It was supposed to be 400, not 800. 200 by 2.
No, I'm talking about this 800 we found this time. I get, so this is 900 here. 900 plus 400 is 13. So that's where we found this one. So 2, 3, that's going to be 3, 6, eh? So 3, 6
Mm-hmm.
plus 8. 3, 6 plus 8. What
36
is it?
plus 8.
Mm-hmm.
36
It's 4, 4.
plus 8
Yeah. So it's
plus
4, 4.
800.
Mm,
Yeah, 4 pin.
yeah. So it's 4,400. This is the initial basic solution. However, the next question is, can you optimize this? That's what we are interested in today. So how do you optimize this now?
So the
So if you're,
initial basic solution is the same as the basic feasible.
yeah, that's the basic one that we have. So now, how do we optimize this? Checking
So what's that?
for, mhm.
So when they ask like you find the basic feasible solution and the initial basic solution is the same thing.
Yeah, it's the basic solution, or the initial basic solution is still the initial feasible solution is still the same stuff, because initial simply
Okay.
means first step. Yeah.
Right.
Okay. So having said that, so I'll just have to erase in these areas that are not allocated. Okay. So this is where we start from. This is where we start from the second step. Now, first of all, we have to check if this rule is always is obeyed, which is m plus n minus 1. It should be equal to the number of allocated sets or cells, allocated cells. How many number of allocated cells do we have?
We have 1, 2, 3, 4, 5, 6. We have 6.
There are 6. So when we do this formula, it should be agreeing with that. So where m is the number of rows, n is the number of what? Columns. So how many rows do we have? We have 3 rows here. The rows are
Yes.
these that are horizontal. The columns are 4, right? Minus 1. So this is 3 plus 4 is 7. 7 minus 1, which is equal to what? 6. So which means this rule is what? Is obeyed. This is where we start from. Because if this rule is not obeyed, then we take another route. There is another route that you take. You have to make this rule obeyed. So there are some other steps that you need to take to make sure that it is agreeing, all right? Like this condition holds. You have to make it hold. So there are steps that you take to make it hold before you proceed. Is that clear? So as for now, we are working with the basic one. It has held, right? 6 equal to 6, where it is already holding. So let's continue. In the next class, this is where we'll start from. What happens when
Sir,
it is not? Hello?
sir, how are
Go
you
ahead.
counting the rows, please? According to me, when I count the rows and the columns, they are just one and the same. They are 4, 4.
The rows are these that are going this side, like these.
Oh, okay,
You know,
one. Okay.
they're just.
I, then
We
for the
don't
column, one,
include
two.
we don't include supply and demand. Okay, then the columns are these that are vertical, you know.
Oh, napang understand ko demand na supply. That's why yung kala confused.
Okay. All right. So I was saying now, in the next class, we'll find out really what happens now when this condition does not hold. For example, when you find that the number of allocated cells is not equal to this number, designed by this formula. This formula is not holding. What do you do? So that's what we are going to be doing. But as for today, let's limit it to where it is holding, and let's pick it up from there. If you understand this, even the next one will be quite easier, because the only change that will happen is to show you how to make it hold. That's all. Once it holds, you proceed again in the same way. You understand? It will be the same step that you take afterwards. As long as it holds, that is going to be the same way that you'll be doing the same steps, as long as it holds. So the only change will be making it hold. That's all. That part, that's the only part that I'll place an emphasis. The rest, it will be the same stuff. I won't really speak so much about that. Okay. Having said all that, then now that this is holding, look at what you are expected of doing, right? This is what you are
Mm-hmm.
expected of doing. So first of all, you're going to you're going to um you're going to set up the numbers here. There is on top, the very first one is going to be a V1. They usually use the V's. V1, V2, V3, and V what? V4. Then this will be U1, U2, and U what? U3. You're following, eh? So now the condition is
Mm-hmm.
that, follow nicely, the row and the column, which will make U plus the Vj should be equal to Cij. Now Cij is the cell number. This number that is allocated in the cell. Okay. This number that is allocated in the in the cell. Okay. What number is allocated in the cell? And by the rule says that U1 is always equal to 0. So you start with this. This is always equal to 0. Is that clear? Follow the steps. This is always equal to 0. So now, if this U is 0, how much should the
So
be? It
mwenzangu
should,
nina foot na mbele na salila.
I
Kwa hiyo
said,
mm-hmm. Sorry.
U1 is always equal to 0. So you have to make sure that you always set it equal to 0. Then from there, you get U1 and substitute into this formula. Remember, so U1, which is 0 now plus V, it should be equal to what? To Cij. And the Cij in this case is 3. The number which is in the cell that you're looking at. You're looking at cell 1. This is the very first cell. The allocated ones, we are still dealing with the allocated cells only. That's what you're doing at this system. So what should be the value of V? If U is equal to 0, for us to get 3.
Mm. Is it not supposed to be 3? It's
Yeah, it's
yes.
supposed to be 3. It is supposed to be 3. So that you say 0 plus 3, it is equal to that what? To that 3. Is that clear?
Yeah. So
Then we go to,
the Cij is equals to the first allocated cells.
yeah, we deal with allocated cells first of all. So Cij is basically a number that is in that cell, the allocated cell, the number, that is your Cij. Okay. Then when you go to the next allocated cell, it is this one where there is 50. This is a second cell, right? In this second
Mm-hmm.
cell, our U, we already know that our U is 0, and we get 1, which simply means that V2 is supposed to be what? Is supposed to be 1, right? So that you say 1 plus 0 is equal to what? It's
1.
equal to 1. Mm-hmm. Where else do we have an allocated number? It is on U2, right? Down U2.
Yes.
U2.
Okay.
And the allocated number is 6, right? Then
Mm-hmm.
on top of V is 1. How much should be the value of 5? We already have our V. Our V is equal to 1. The Uj is 6. What should be U?
It's a 6.
Now, like our V is already 1. Like we already have 1. When you add V plus U, they should give you this 6, the Ij.
So this 1. Hello.
Yes, the V is 1 on top in this column. Like the V is in the column section. It's 1 on top there. How much should be the row? Like it's
It should
basic.
also
You
be
just
3.
add the U plus the, it's supposed to be?
3. You said that the V is 3, right?
No, V2 is 1 here on top. Are you able to see the screen? It's 1, like there's 1 on top. Then U2 is what? This U2, like in this column. Suppose that we get 6, that's what you're saying. Anyway, it is going to be equal to 5. So that when you add 5U plus 1, giving you what? 6. Okay?
Okay.
Yeah. It's the same stuff that we did in the first, in this first row. So when we get to this 500, the other one, where there is 5 and 100, our U now is 5. Then our V3 is supposed to be how much? What about V3?
Our U is 5.
And U2 is 5. Then our cell number is 5. What would be V3?
It should be 2. It should be 1.
Are you seeing the formula that I've written? Simple, just get this formula that I've written. Say U5 plus V is equal to what? To 5, like that. So what number should we put here on V so that we get 5? This is already 5.
1. 1.
Are you sure when we add 5 plus 1, we'll get 5?
No, it's supposed to be 0.
Yeah. Malema boss. Overcourse.
No, can you stop confused kabina ka formula?
Like just add U plus V is equal to Cij. That's all.
Because per
All
first
right.
term, we U is equals to 0.
Are you
So
writing
multiply
anyway?
number. Yes.
Oh, okay. Then we can go to the next one, the next cell. Our next cell is what? Is 5 and is this one? Where there's this shoe was 300 actually. So it's
It was 3.
303. So our U we don't have. U plus V, our V is what?
3.
What's our V in that column? It's 0.
3.
Like V
That's
on top.
why. The V on top. So we are getting the V3.
Yeah. Then plus the Cij is equal to 3. Okay. So what should be the value of U?
3.
Yeah, so U should be equal to 3, so that when you say 3 plus 0, you get 3. Namanje mukaribu akagwira. We get to the last one where there is 200 here. Yeah. Still, you write U plus V. The issue is just begin by writing U plus V is equal to Cij, the number which is in the cell. Do like that. That's where you start from. Then look at the left, look to the right. At the left, you have U along the rows. U is 3. How much should be V so that you get 2?
Supposed to be -1.
Yeah, so it is supposed to be -1. So V4 is equal to -1. Simple like that. Okay. Once we are done doing this, we are done with the VC step. If we are done with this step, then we need to find the penalties using what we have done now. We need to find the penalties for the unallocated cells, right? Find the penalties for the unallocated cells. Find the penalties for the unallocated cells. Let me just erase these. Find the penalties for the unallocated cells. To find the penalty, this is how we find the penalties. This is a formula. Pj is equal to U plus Z Vij minus Cij. You've seen. So U plus C Vj plus Cij. Simple. So just add, okay? U and V, we add them, then minus Cij. You got it, eh?
Just for each cell.
On each of the unallocated cells, like these we are dealing with unallocated cells now. But before you do that, you have to get the numbers, the codes for the unallocated cells. Remember, these that are going there, these are the cells. These are cells. Cells are named by, it's a cell row by column. You get it? That's how we name. The cell number will be row by column, will be named by a row by column. Row by column.
What do you mean
Okay.
by row by column?
Like you mention the number of a row, then you mention the column number. Simple. For example, here on 7 is not allocated, right? Like we are starting with the those which have not been allocated, right? Now we are dealing with the unallocated. So 7 is in row 1, right? So it will be C1 what? What is the column number? The column number is 1, 2, 3, right? This is C1, 3. That's what we mean. Nothing much, nothing fancy. It's just that. Row by column. So it is C 1, 3, like that, is equal to. Then the next one, there where there is 4, obviously this will be C1 what? C row 1, column 4. Isn't it? What about here where there is 2? What will be the cell number?
C1, C1, 1.
What is the row number here where there is 2?
Oh, the row number is 2, so it will be 2, 1.
Yeah. So it's 2, 1. Yeah. 2, 1 equals to. Then where else? The other one is C 2, 4, right? Here where there is 9. And here where there is 4 is C, where there is 8 is C3, 1. And the C3, 2. Right? You're following? These are codes. Simple. Now you need to be understanding these steps so that you're progressing. So from here, the next thing that you're going to do is just see, let's start with the first cell. C13. Here. We start with the U. What is the U here? It's basically 0, right? U is 0 in that row, right? Row is
Yes,
0 plus another 0 minus the cell number is 7, which will give us -7, right? Yeah?
yes, sir.
Okay. And then we go to the next one, C14. What is the U number here is 0. V is -1, minus 4, which will give us what? -5, right?
Yes.
And again, you will go to the next number here, which is C what? C24. Or C21. C21, which our U is 5 here. Our 3 is what? Or our V is 3. -2.
This one I use
What
what
number
number
do you
course?
find? C21.
Which one is C21?
Cell in the row 2, column 1.
So we're finding for 2.
Yeah, like we are finding for this cell number. These are cell codes. The cell code we have allocated is 2, 1. So which means the cell which is in the second row and in the first column. So it's this one. That is the cell which has got that definition. So our U is 5 plus 3 minus 2, which will give us 6, positive 6, right? Now C2,
Mm-hmm.
4. Yeah.
C2, 4.
So what is our U? Our U is still 5, isn't it? C2, 4 is this one.
Mm. So nangaya manamba
Our
ari
U
kuma
is
U.
still what?
Basa. Sa.
Hmm?
Aya manamba ari kuma U
Mm-hmm.
yachwa kuti. Kuri U1 equals to 0, U2 equals to 5, yachwa kuti ndepeni yawo. Ndepe mwaikako.
We were putting them together with you. No,
Mwatisa kuti.
we were putting them together with you. You have forgotten.
No, I wasn't there.
Uh-uh. You were not there.
I got
We were
confused so
putting them
nailala.
together. When I gave you, when we was doing U plus V is equal to Cij. You remember this? And we're dealing with the allocated cells only. When I was saying when you add
So
U
these
plus
are
V
the
is equal to the
CIJ.
cell number. No, the Cij
So those
is
are the
these
CIJ.
allocated numbers like 2, 6, C3. I said the Cij are these numbers like in the cells. These are the Cijs. That's what I said. Hmm?
And
So
then
I
I
was
am a
saying,
05. Mm-hmm.
which one?
These the U1s, U2, U3. Those my numbers. What would say?
Okay. I think let me just go back again where we started from. I was saying when we started with the right.
Hello.
Hello, I'm trying to get back to where we started from so that you can pay attention now. So I was saying we when we had I think you remember after finding initial basic solution where we ended. From there,
Mm-hmm.
we had ended on this part where we had done already the allocation, right? Then I said from there, when you have to move to another step where you're finding now the optimum solution, the first thing that you need to do is to allocate these numbers, the U, like U1, U2, U3, like these are rows, okay? The rows, first allocate them. The row 1 will be U1, row 2, U2, row 3, U3. The rows are these which are horizontal. then the columns will be given the V's, like V1, column 1, V2, column 2, V3, column 3, like that, up to the last column. Okay, that's the first step that you do when you're finding the initial basic solution. Okay?
Okay.
Then from there, I said that it's by rule that always U1 is equal to what? Is equal to 0. It's always equal to 0. Then if it is equal to 0, it should be made in such a way that when you add U plus V, they should equal to what? Cij. And I said Cij are these numbers in the cells. But this time around, we are just concentrating on what? On the allocated cells, these cells which have allocations. You got it, eh? That's what we are doing this time around. We are looking at these cells which are allocated. So these numbers which are allocated like this, when 3, 1, 2, 6, and 3, and 2e, these are your Cij. That's what we said. I hope you are following now. So after saying that, the next thing now that you do is these numbers, for you to find now the V, the U, and the rest, you have to make sure that you use this formula here. Use this formula, okay? So for example, to find the V1, since we already have U, we just have to put our U is what? 0 in the first cell here. Our U is 0, right? Plus V, we don't know, is equal to Cij. What is the Cij in the first column, in the first cell? It is a 3, right?
3.
That's
Yes.
right. So I was saying now, what is the value of V? So it will be 0 plus V is equal to 3. What number can we add with 0 to give us 3? That was the question. Then we said we can only add 3 so that we get 3, right? From 0.
Yes.
If you add the 3 plus 0, you get 3. That's how we find the V1. Okay. Then from there, we go to the next, to this next cell. Only allocated cells are the ones that we are paying attention to. This next one where there is 50. What is the Cij here? The Cij is 50, is 1, right? The Cij is 1. Like you put 1. Then what is your U? Your U is 0 in this row. We are still dealing with the first row where U is 0. So say 0 plus V. V you don't know in this case. So what number can you add to 0 so that you get 1? We say D, it is equal to what? 1. Now you remember, you're following.
Yeah.
Okay, then we are done with the allocated cells in the first row. You move to the second column, the second row. Okay, here where there is 6, there is a cell that is allocated. All right, again, you repeat the same. What is the Cij? First of all, put the Cij. It's 6, right? It's 6 here, that's the Cij, cell number. Then you ask yourself, what is the U? U you don't know. Plus, what is your V? Your V is 1, right? V is vertical like the column number. It's 1. So you say, what number can you add U plus 1 to get 6? Or in other words, can you make U the subject of the formula? Isn't it? Right?
Yes.
Work out U, find U. What value, what number can you add with 1 to get 6? That's a question. Simply say 6
5.
minus 1, you get 5. That's how you find the 5. Again, we said that when you get to the next one, the next allocated number will be this one where there is 5. So Zij is equal to 5. What is our U? Our U now in this case is 5, right? It's here, like in the raw number is U is equal to 5. But what is our V? Our V we don't know. You get that is V3. We don't know our V. What number can we add to 5 to get 5? It can only be 0,
0.
right? That's what we are doing. Then you come to the last column. Come to the last column where we say that is on 300 here. The Cij is 3. So we have the u plus what? Plus v. Our v is already 0. We already have 0. The v is 0. So what is our u? Our u can only be 3, right? So that we get 3 when we add to 0. That's how we found this is 3. And then now we come to this one where there is 200. What is the Cij? The Cij is what? It's 2. What is the u? The u is 3 plus v. So we said, what number can we add to v so that, to 3 so that we get 2? You say this -1. It was you who said this. So that when you say 3 minus 1, you get 2. That's how we were finding them. We go over it again. Okay. So from there now, we are done with that stage. Let's move together. You go to another stage where you are now dealing with the cells which are not allocated. You put penalties using this this formula. So that's what we are doing now. So we were dealing with this penalty. So we are going to C24. C24. C24 here where there is 9. Here there it is empty. It's an allocated cell. So what is the value of u? Is 5 minus 1. All right. Then minus 9. This is 4 minus 9, which will be -5. So this is -5. Okay. Again, you go to the next one. Which one is unallocated again? This 8 one. What is the v? Our u is 3, right? And v is 3. So this is 6. 3 plus 3, 6 minus 8, it will be -2, right?
Yes.
And then when you get here on 3, it will be 3. U is 3 plus 1. That will be 4. 3 plus 1 is 4 minus 3 is 1, is +1. Is that clear? We need to be a bit fast, otherwise it will take us quite a lot of time. Yeah. So when you're done with this, then you have to check the condition. If P,
the v is not supposed to be 0.
Which one?
On 3.
Here. What is our u on 3? What is the u? Are you able to see the screen?
Yes.
What is the u?
The
Like
u
the
is
row?
3, then the v is 1.
Yes, so you add, is u plus v. 3 plus 1 is 4. 4 minus this Cij, this number here, this 3, is 1. 4 minus 3 is 1. Right?
So these are the PJ, the ones we found.
Yeah, these are the PJs, the penalties. So now, so the rule is the optimal condition can only be reached at a point where the PJ, the penalties, are less or equal to 0. You get. In short, you should not find a positive number. As long as there is a positive number, then you have to do what? You have to progress again. But in our case, unfortunately, there is a what? There is a positive number. There are 2 positive numbers, actually. There is this one and this one.
Yes.
So, which means this answer that you found was not optimal. You have to find an optimal one. How do you find an optimal? Now you need to look at the maximum of the positive numbers, which is only 6. You're following, right? I'll be a bit faster now. We want to be a bit faster. So it's on this 6. That's where you find a positive number. That is maximum. You compare between these two positive numbers. Which one is big? It's this one, isn't it?
Six.
It's 6.
Mm-hmm.
So what is the cell number? The cell number is cell 2, 1, right? The cell in the second row in the first column, which is particularly this cell. You're following, eh? This is this cell
Yes.
here. Okay. So when you do that, when you identify the cell now, listen, you need to draw a closed loop. A closed loop. Okay, a closed loop. But how do you calculate the closed loop? So it's more like we are starting afresh, what we are doing. So when you draw a closed loop, listen, the rules are you can only move horizontal or vertical, and you can only turn at a point where there is an allocated cell. You're getting it, right?
Mm-hmm.
You can only move at a point where you can only move horizontal and turn on at a point where there is a positive or a negative. And in this case, when you start from this point, this is a starting point, cell 2. So we can move to the right up to here. This is an allocated cell, right?
Mm-hmm.
We can turn upward. And again, upward, we have found another allocated cell. We can still turn to the left. Again, we have found another allocated cell. Then you can come back down to where you started from. This is a closed loop. We call this a closed loop. It can be drawn in any way, but as long as you are following the rules are that you can only turn where you find an allocated cell. And again, you can only move horizontally or vertically, not diagonal. It can only be horizontal or vertical. When you do this, when you are done doing this, you have to come back where you started from if you're drawing a closed loop. That's what happens. Okay? Now listen, when you find a closed loop like this one, there will be positive, negative, positive, negative. You have to alternate your signs from starting from your starting point as positive in the corners, where you start from,
Mm-hmm.
it's positive. Your next step will be negative. Then where you went again, it will be positive. The next one will be negative. Where you start from is always positive. So it means that this one will be positive. You're following, eh? At this corner, it will
Mm-hmm.
be negative. This one will be positive. The other one will be negative.
Negative.
You're following, eh? Follow
Yes.
nicely now. We are speeding up a bit. So when you get here, in these numbers where there are negatives, check one of the minimum negatives, right? One of the
Mm-hmm.
minimum what? Negatives. Which
Negative.
one is the minimum negative? Minimum negative
Three.
on this allocated number. The other one is 300. The other one is 250. You get it, right? They are allocated
Mm-hmm.
numbers. The other one is 250. The other one is 300. Or definitely 250 is what? Is the minimum, isn't it? It's the smallest. Okay?
Mm-hmm.
So now that 250 is the smallest, you have to deduct it everywhere in these corners where there is a negative and add it where there are positives. Meanwhile, these other numbers like these, when 200, these other ones, these other cells that are not, should be just like this. Don't change them. You understand? Leave them the way how they
Mm-hmm.
are. So in short, we want to allocate a certain cell again. So how are we going to do it? We are adding, right? Where we are supposed to add, we add. Where you're supposed to deduct, we deduct. So let's go. Where there is 250 here, we deduct 250. What are we going to remain with?
Zero.
We'll remain with 0. So there is no allocation here. We have agreed, right? Oh,
Mm-hmm.
there will be no allocation there in the next round. All right? There is no
Yes.
allocation there. Then let's see, come to this other one. He has a 300. 300 minus 250 has what?
50.
It will give us 50. So here we change. We'll put what? We'll put 50. You are following, right? So where there are negatives, the smallest number should be deducted across. Or in each point where there is a negative, deduct that smallest number. Then you should add now in those other corners where there are positives. For example, here where there is 50, there is positive, isn't it? This 50 here where there is one, the blue one, the 50 which is blue, there is a positive there, right? According to what I've drawn here, that's what we are looking at. There is a positive number, right? Hello? Hello?
Hello?
Yes. I said that there is a positive on this 50, which is blue, right? According to this, what I've drawn here, my positive, negative, positive, negative. On this corner, there is a positive. You need to add that 250, right? So it will become 300 short, right? There was a
Yes.
250 there. It will become 300. Then here, there was nothing on it too, right? There was
Mm-hmm.
nothing here. So when you add 250, it will have now a new allocation of what?
Okay.
250. Okay. Now, when you reach at this stage, again, you go back to step one. What is in step one? You have to check if the condition is being met. This one, minus one is equal to the number of allocated cells. How many allocated cells do we have?
6.
There are 1, 2, 3, 4, 5, 6. There are 6, right? So
Mm-hmm.
the rows are 3 plus 4 minus 1 is still 66, which means the condition is still what? Met. You're seeing that, right? The condition
Mm-hmm.
is still balancing. Then we start afresh what we are doing. See, now we are repeating the same thing. What is our U? Our U1 is
Oh, you is
0, isn't
0.
it?
Yes.
Which means our V1 will be what? 0
Um,
plus it will be what? We are just dealing with the allocated cells, first of all.
okay.
So U plus V is equal to Cij. That's what you're doing. Cij is 1, right? There's 1 here. Cij is 1. So you say 0, like U is 0 plus V equals to 1, which means our V will be equal to what? Will be 1, right?
Our view will equal to 1. Yes.
Yeah. Then when you get here, obvious again, this V, that was our V. There is no V1 yet. We just have V2. This is V1. We haven't found it. We have V2. V2 is equal to 1. Where else do we have allocated number here down? Where there is U2. All
Me
right.
too.
Yeah. Where there is U2. How do you find U2? We can only use this vertical line. We can only start with 6 here because at least on top here there is V1. Let's use the one for 6, where there is at least V. You've seen, eh? There is at least V
Mm-hmm.
there. V is 1, which means our U will be equal to what? Will be 5,
5.
right? Then now, if our U is 5, to get 2 here, what will be our V1?
To get which 2?
This 2 here, we are looking at this cell where there is 250. This cell where there is 250.
Okay. So it will be 5 plus 0 equals to 2. So it will be
So the
negative 3.
Cij, yeah, is 2 minus 3. So it's negative 3. Then again, we come to this one,
The 5.
where there is 5 here. What will be V? This will be V3 now. What will be V3?
So to be 0.
Yeah, it will be 0 because it will be 5 plus 0 equal to 5. You come down now
Mm.
to this one, U3, which will be our V. We are on this 300. Our V is 0.
Yeah.
Yes. Then our U will be what? If our CJ is free, it will be 3, right?
Yes.
Mm-hmm. Then our V1 will be equal to what? Our V, we know
It
that
will be
our
-1.
-1. Simple. So again, when we get here, what do we do now? We find the penalties. I'll maybe it fast now because we are repeating the same stuff. Penalties are found by saying U plus V minus Cij is equal to penalty. Let's find the cell numbers. This is C11, right? On 3 here. Then on 7, it will be C13, right? On 4,
Yes.
it will be C14. Okay. Where else? C2 on 9, C24. Then
8.
is C3 1 on 8.
3.
And on 3, it will be C what?
It
C3
is C2.
2.
C3.
Yeah. That's that. Then let's do the penalties quick. C11 on 3 here, it will be 0 plus 3 minus 3. Oh, this is -3, eh?
Yes.
Is it -3 or is it just 3? Oh, it was
-3.
-3. Yeah. So it will be 0 minus 3 minus 3. This will be -6, right?
Mm-hmm.
On 7, 0 plus 0 minus 7, it will be -7. On 4, 0 plus 0 minus 1 minus 4, it will be -5, right?
Mm-hmm.
On 9, it will be 5 minus 1, which will be 4 minus 9, it will be -5. On 8, it will be 3 minus 3, which will be 0 again, minus 8, -8, right? You're following, eh?
Yes.
Then on 3 here, it will be 3 plus, are we doing the right thing, huh? We're on C3, 2, yeah. So it will be 3,
+1. C +1 minus 3.
which is 0.
Mm-hmm.
Oh, okay. Interesting. This one has met all the conditions. You've seen, eh? The PIJ,
So I feel
yeah. The PJ, this one is now less or equal to what? To 0. At least in
0.
other number. So as long as there is no positive, it means now you have reached the what? The equilibrium or the feasible solution, so we can erase at this point. This is how you test. So what is the feasible cost? The feasible cost, now you will find it the way how you have been finding everything. Just focus on the allocated numbers. You will conclude like this. 300 times 1 plus what? 250 times 2
50 times
plus
6.
50 times 6 plus 500, which is 100 times 5, plus 300 times 3, which is 900, plus
That's
400.
400. Hmm.
Yeah. Then you work out this stuff.
So this is the feasible solution,
That is
the
the feasible
feasible
solution.
cost
Mhm.
per solution.
This is the feasible cost. It depends on what the question is asking you. This is the cost of transportation. In other questions, like they can ask you of the, you remember in your assignment, they were asking you for the minimum distance. So it will be the feasible distance, which means the minimum distance. Yeah, like that is the minimum distance that you would find using what? The optimal distance using VAM. So you just follow the method that they have given you, right? So this is how you use the MOD methods, because the MOD method, this is called the MOD method, right? MOD method is that, and that's how you find feasibility or optimal solutions. Okay.